Okay, so we are going to start off with an example of an ice table, but we're going to use a perfect square trick to help us out of any complicated math. So, first of all, we are looking at the equation up here. So we've got N2 plus O2, equilibrium arrows goes to 2NO gas. Now they've given us the K value, and it says determine the equilibrium concentrations for all species present, given that the initial concentrations of each reactant is 0.200 moles per liter. So the idea here is that they've given us the initial, okay, so right here, we've got an initial concentration, and likewise for this one. So if they don't say anything about the products, we assume it starts at 0. Now our change we take into account by minusing x, and we add 2x here because this is our product. So you can pretend that little equilibrium arrows are sitting right here. Okay? So with algebra, we're left with 0.200 minus x, 0.200 minus x, and 2x. Now, if this was an easy ice table, they'd give us some out at this point. They'd say, okay, 2x is equal to 4, solve for x, and then we would go back and solve for the rest of our equilibrium concentrations. But this is not one of those super straightforward ice tables. So there's a little bit of math that we have to do. So what we're going to do is write our K expression. Now, our K expression is exactly like what we would do from our practice yesterday. We would take our concentration of our products, knowing that it's squared because it has the coefficient 2, over the concentration of our reactants. Okay? So this is what we have to work with. Now, at this point, because they gave us the K value, we're going to substitute it in. So 0.00250 is our K value. Well, I don't really know anything about the NO except for the fact that it's a 2x. Don't forget, though, that we have to square the concentration of that. Okay, that's the number one thing students usually leave out. Under N2 and O2, we're going to put in what we know. And what we know is that they're each 0.200 minus x. Well, 0.200 minus x times 0.200 minus x is the same as writing it as a square. It's important you recognize that because at this point, the perfect square is kind of given away by the fact that you have a square on the top and the bottom. Now, you would have a lot of complicated math to do if we could not simplify this, but it's not in your curriculum to do any of the quadratic equation formulas, so we're going to find a little helpful hint, and that hint is using the perfect square. So at this point, if you square root this side, you're going to get rid of this square and this square. But in math, anytime you square root one side, you have to square root the other as well. Okay? So we're left now having to simplify this. So if I have 0.00250 and I square root it in my calculator, making sure you and your calculator are getting along. If you're not sure where the square root button is, please let me know. Okay, so we get an answer of 0.05. So I'm just going to write that underneath, 0.05. Okay, and then on the left, or on the right side, we still have everything except for the squares. Don't forget about that. Okay, now there's still a little bit more math to do. Now, I'm going to leave it at this point and go to the next page. So I'm just going to copy this. Okay, so we're working on the second page. I'll erase some of my work just so you can see where we're going from here. Okay, so we left off with 0.05 is equal to, and then we had on top 2x, and then on the bottom 0.2 minus x. Okay? Now, in order to simplify at this point, you have to get the 0.200 minus x off the bottom. So to do that, we're going to multiply it on this side as well as over here. Okay? So just to show that, we've got 0.200 minus x, and we're multiplying that by what was still originally on the left, 0.05. Now, don't forget it's still equal to 2x. Now, you've done some fancy chemistry at the top, but don't forget your simple math rules. So 0.200 has to be multiplied by 0.05, and you also have to multiply it by the x. So I end up with, if you take in your calculator, 0.2 and times by 0.05, you get 0.01. Okay? But then don't forget, that's going to be subtract x times 0.05, so 0.05x. Okay? So we're simplifying, doing a little bit of math. Now we have to get the x's to the same side, so you're going to add 0.05x, add 0.05x. Okay, so just going up here, we now have 0.01 equals 2.05x. Okay, so the last step to get the x completely alone, we're going to divide out the 2.05. Again, in math, whatever you do to one side, you have to do to the other side. Okay? So this cancels, and x, if you plug it into your calculator, 0.01 divided by 2.05 gives you 0.00. I'll erase that quick. Oh, that erased a lot more. Okay, I'll throw that back in, 2.05. Alright, so x equals 0.004878. Now that's awesome. You did a lot of work to get x, but you haven't answered the question. The question is still, what are the equilibrium concentrations? So, now that I know what x is, I'm simply going to sub it back into these equations. So, 2 times x, I take that number, times it by 2, and I get 0.009. Now, it would be 756, but if you look, we're only allowed 3 sig digs, so I'm going to make it 976. Okay, so we're rounding. Now, if you were expressing this as an answer, please don't forget you should put moles per liter behind these numbers, because these are concentrations. Okay? So going back to our reactants, 0.2 minus 0.004878. Remember, try to keep as many real numbers as you can so you're not rounding and having rounding errors. So this would be 0.195, and this would be the exact same because it's the exact same equation. Okay? So that was an ice table question. We set up the ice table exactly the same. We set up our Kc, our equilibrium law expression, exactly the same. When we subbed things in, we noticed that we ran into a problem. There was no easy out. So we used the perfect square, and we knew that it was the perfect square because we originally had a square on top and on bottom. How did we get rid of it? We square rooted both sides and then finished by solving for x. Now don't forget, x is a beautiful number, but it's not your answer. You have to come back up and actually finish solving the question. Alright, I hope that made sense, and if you have questions, please come in and talk to me.